Okay, so now we're going to, 11C is working with matrices, transition matrices, and we're going to be using recursion. So if you remember back to, we did recursion, it's a way of describing a sequence or a pattern. And all it means is, because we're talking about transition, and I mentioned it before, we're going to say that, you know, we have this initial state. So what's happening in the beginning. And then we use the transition to get the next state, so which we might call state 1. And then you would get, you know, so what's happening. So if we talk about like that car rental place, it'd be like after, you know, so many days, you know, how many cars are at each of the stations. And that's what we're talking about. So what we're going to say is we use recurrence relation. So what you'll see is you see this Sn plus 1. So what that means is this is the term used. So the term used to state how to get the next state, yeah? How to get the next state. So that's why it says n plus 1, because, you know, that's how we'll get the next one. And generally what we're going to see is the way we get the next term is we use the transition and we times it by the state before. So if you want to get S1, you would use the transition times SO. If you wanted to get S2, you're going to use the transition times S1. So that's all that means. And that's when you do that, that's called a recurrence relation. So we had a very similar thing. So we're often they're going to talk about the initial state, which means in the beginning, the SO. So remember in finance, we called it VO. Remember, it was the value or the, you know, the principal, the starting value. We're just going to have the same. It's SO because we call it, when we're doing matrices, we call it the state, you know, whatever we're talking about. So let's have a look. So that's a recurrence relation. And so we're going to be using that. So let's have a look at this example. It says a factory has a large number of machines. The machines can be in two states, either operating or broken. We saw this one the other day. And broken machines are repaired and come back into operation, and vice versa. Now, it says here, at the start, 80 machines were operating and 10 were broken. So when they say that, they are setting up the initial state here. And what they're saying, and we know because we've got two options, we're either operating or broken, and they'll tell you. So you know in the beginning there were 80 machines operating and 10 broken. 20, sorry, broken. So how many machines are there in total in this place?
100.
100, good. And it's always good to make sure that you realise that. So even though the transition, we're going to find, they're going to juggle around. Some are going to be operating, some are going to be broken. But what you've got to remember, that the total remains the same. So it remains the same in this scenario. So in this case, there's 100, okay? So that's a good way to know, because sometimes when you're rounding, you need to be careful. They have to always be adding up to 100. So it says here, it says use this recurrence relation. So really what this has said right here is just what I explained to you. The way we can get the next state, so the next day, is we can try the transition by the day before. So it says here, we've got the SO and they've given us the transition. Now it says determine the number of operating and broken machines after 1 day and after 3 days. Okay, so if we're using recurrence relation, so what we're going to do is we're going to show the steps. So if I want to find state 1, what I do is I do the transition times SO. So you don't have to write out, you know, see how they've called transition T? You don't have to on your paper keep writing out the actual numbers. You can get away with just writing T, and I often just do that. And because the SO is only two little numbers, we'll do that. So when you do that on your calculator, you end up with, and I've done it up here. So here's the transition times SO. We end up with 69 on the top and 31. Now, do those total up to 100?
Yeah.
Yep, that's good. And remember, this was operating and the bottom was broken. So they actually asked in the question, determine the number of machines operating and broken. So we would make a statement. So just write, you can just write it, 69 operating, 31 broken. As long as you bring it out of the matrix and write a little statement like that, that's good. Now, they want S3. So if we're doing it recursively, that means I'll have to get S2 first. So S2 would be found by going the transition times the one before, which would be S1. So what you're doing is you're taking this answer, because this is S1, and you're popping it into there. So, and then you do that. So if you look over at here, I've got this ends up being S1. So transition times S1. So just to help you, let's just write that out. So that was SO. S1 was when we had, and we wrote that out, and we end up, now it's over here. I'm going to round it because we're not going to have a 0.2 machine. We're going to round it. So I'm going to round that top number to 60, and the bottom number does round to 40, and that's okay because does that add up to 100? It does, doesn't it? So that's good. So we didn't really want S2, but we needed it to get for S3 because the way I'm finding S3 is by timesing the state before, which would be S2. So here I go, off I go. Now just to show you, so we're using that 60-40, and we ended up, and you can see, actually I didn't sort of round here. I probably should have rounded it when I did it, but it's okay. So I put it in and I'll get 53 and 47. Does that round to 100? Yeah. So this one was S2. So this is S2. Okay, so it said to state it. So we'll say 53 operating and 47 broken. Okay, so it can be a bit annoying if we were doing the recursion way, and see how we had to do to get S3. We had to go through S2 and get that. Now, what if I say, this is a car rental company. Who cares after 2 days? I might say after 2 weeks, what's happened? So that'd be S14. That we don't want to do it recursively. So what you can do is you'll hear me say, use the power trick. And here is the rule here, is how to get any state, like how you can get any state using the initial, yeah? Which is SO. Okay, so all you have to do is, you see here, they've got, if you were like, so if that letter S, so say I wanted to, I'll do it in an example. So say I said before I want to find state 14. What I do is I do the transition to the power of 14 and I times it by SO. So if you do that, it will get you there quicker. So do you remember we had the nth term in finance? Remember, because we didn't want to be there forever, so we just did this. So a trick to working it out, and this is just to help you. See this number 14, we want 14. When you want, if the state you want, the power, the power and the, the power and this number here, they need to add up to what you want. So does 14 plus 0 equal 14? Does that work? Yes? So that means it'll get you there. So the reason I'm telling you this, because this power trick, say you want state 14, but you don't actually know the initial, they gave you, say they gave you state 4. You know, they said 4 days in, this is what is happening. So what I'm saying, what do you think the power needs to be if I want to find state 14?
10.
Yeah, good, 10. So we'll put that to 10. So you can see that if that number and this number, so 10 plus 4 equals 14, that will give me that state 14. That's just to help you, because sometimes, you know, in a trickier question, they might not give you the original. They'll give you some state, and you just have to get to it by knowing how many to get up to. All right, so let's have a look at this example here. It says a factory has a large number, we've still got the operating and broken machines, and here it says, so they said determine how many operating and broken machines after the 10 days. So you want state 10. So if you want state 10, you're going to do the transition to the power of 10. Now they gave me SO, so that's why I'm doing that. And so, as I said, you don't need to keep writing out. You can use the letter T like what I'm doing, and you could, because they gave you SO, you can even leave it as SO, but I'll just show you. And we pop that in, and we get 31 and 69 that way. Now this was operating and broken, so just make sure, because it said how many, they didn't want it in a matrix, but you should show you working out, but then write 31 operating and 69 are broken. So we have a transition matrix, and we know that the state matrix is S4 is equal to this. Now it says it wants to determine S3 and S2. Can you see we want to go backwards, don't we? They want me to go backwards. So the power trick will still work. So if you think about it, I'm going to say, all right, they want S3. And obviously I'll use my transition, and there's going to be a number put up here, and I'll times by, well, they're giving me S4. Okay? Now, if I want my number to be 3, so something plus 4 needs to equal 3. So what would that be?
-1.
-1. So that means the power up there is going to be -1. Does that make sense? It's such an easy way to work it out then, because then you just go, all right, that will give me 3, and off I go. So you can see I've done the transition here, and this was S4, and we end up with this answer. So I'm going to write it out. So 252903470. Okay, so if I wanted to go S2, you don't ever want to use something you found out. You want to keep using what they gave you. So once again, I've got the transition. I'm going to raise it to some power, and they gave me S4. So if I think about it, this number needs to be 2. So something plus 4 needs to give me 2. So what does it need to be? -2. Good. So that means that power up there is -2. And you can see I did it here. So this was S4. And we ended up with the answer of 24300 and 35700. Now, you would notice if you added these up, the totals remain the same. We never lose at this. When we're doing the transition like this, we aren't adding any or subtracting any new things. So the totals should add up. So why I say that is because you've got to be careful. Sometimes when you have a 0.5, both of them are 0.5, you know, normally rules say we round up, don't we? So you're going to have to give it to one and not to the other. And it won't matter. Say you go, well, how do I know which one to give it to? It's okay. We're going to check that you've only given it to one and you reduce the other, okay? So I'm just going to say this is a side note. So I'm just saying, like, say your state 0 was, I don't know, I'm making this up, so 2080. So you know it's a total of 100. Say you get down to, I'm making this whole scenario up. So if we get down to, say, state 25, and we get 15.5, and we get, say, what do we say, 84.5, yeah? If you round them, the correct rounding, that would take you to, say we did that properly, that would be 16 and 85. Now that actually is what? 101. So this is what I'm saying is you can't do that. You can't have it. You can't lose or gain one. So what you have to do is choose one. And so I might just choose that to be 15 and I'll choose that one to go up. That's okay. Yeah, it's okay to do that, and we're going to expect you to know that, because what we want to know is to make sure that they're 100, okay? So when you're faced with that dilemma that it goes up, change one so that it rounds to what you should have, okay? Okay, so now we've got this thing called the steady state. So once you'll notice, so if you have a look here, we've got the steady state. Well, what it represents is the equilibrium. Equilibrium means when you get to a point that it just remains the same. It doesn't change anymore, okay? So after you can watch, after a certain amount of transitions, and it'll vary depending on the scenario, but eventually what happens is you hit an equilibrium, which means, like, say with the car rental place, we would eventually hit, after so many days, it's not going to change. So this probably becomes important for the company, because they're going to say, really, on a whole, we're going to want this many cars at that campus, this many cars there, and all that. So if you have a look here, we've got one we're showing you with the transition, and they did it to the power of 2. And you can see here they've gone up to the power of 16. And then when they did 50 and the power of 51, you can see how it's not changing now. So that means what we've hit is sometimes it's called the steady state or the long term. So that's why that's important that I put up there, because they may use the wording long term or the steady state. So, you know, we can slowly see it. If we kept on going one by one, we will eventually hit the steady state. But sometimes, like, we're not going to be there. Sometimes it might happen at 20. Sometimes it might happen at 30. So what a rule of thumb is, we generally just throw it to a high power and you will get there. And normally the power of 50 will do it. So you might want to say, when you're finding the steady state, you're going to do the transition to the power of 50 times, you can say SO, it can be any state really, you are going to get there. Okay, so, and the power of 50 will get it there. But what you have to do is often you need to prove that you have hit the steady state. So to prove it, you should put the T times 51 and show that it equals the same. Yeah, so just show that they're the same. And you'll see that in a SAC or an exam. They might say, show that the steady state is this, or they'll say, find and prove that this is what the steady state is. So you just do it to a high power. Down here, they're just saying, they might just refer to it as a high power. We found 50 will get you there generally, 50 and 51. And it's good to check yourself, just in case there might be a rare scenario 50 doesn't get it. But we found, if we used to say 100, but the calculator actually tries to zoom it over in its thing, and sometimes it gets locked in calculating, so it takes too long, so don't do that. All right, so let's have a go. It says this is the car rental problem again. Estimate the steady state by calculating the state for 10, 15, 17, and 18. So all we have to do here is, so for S10, remember, we do the transition times the power of 10, because we got SO. And I've done that here. Now, how many cars did we have in this problem in total? 90. So we better make sure that it's 90 to do it. So this first one I would round to 31 and the bottom one would be 59. That's okay. Does that go to 90? Yeah? It does? Yeah, good. So the next one, they wanted 15. So I do transition to the power of 15. Now I've got it over here. It rounded to 30 and that bottom one rounded to 60. So is that, that's 90? Yeah, so we're good. S17. So we're doing that one to the power of 17 times SO, and we end up with 30 and it rounds to 60. So can you see, are we starting to not change? Yeah. So, and then if I do T18, SO, if I round it, I end up with 30 and 60. So I'm showing it's not, we've reached a steady state, haven't we? It's not changing. So you could see here, they went from here to here. That's still a jump of 2. It didn't change. So then they just did one after, and now they're showing that the steady state is there. So this is now what we would say is the steady state. It's always going to be 30, 60. So say this was the car rental with the 2 places. I think it was like Bendigo and Colac. We'll keep 30 cars at Bendigo and 60 at Colac. So we've sort of gone over this, but I can email this out to you. But anyway, let's just go through. So to find the steady state quickly, raise the T to a high power. So I said that. Let's raise it to 50. To prove you have the steady state, you must show 2 consecutive state calculations. What do I mean by consecutive?
In a row.
Yeah, in a row. Okay, so can you see how I'm showing T50 and then T51 equals the same? You don't have to type it all out, all right? You can just keep using the T, you know, the symbolize, and do it like that. And then it doesn't matter which state you use to find the steady state. The high, if you put the transition to a high power, you will get there no matter what. And that sort of makes sense. So say they gave me S5. Well, I do transition to the power of 50 times S5, I'll get there. And that's what it will do it. Now, so I just showed you. So it doesn't matter what state. So if you look at before, you know how we said we had a total of 90 cars? Did you remember before? So I used the same thing and I just chucked 90 into the state, but I put them all in one spot. Did I still end up with the same steady state? I did, didn't I? Yeah? So what it actually means, it doesn't even matter how they're jumbled up. Does that make sense? So that's an important fact to remember, because when you're problem solving, you might not be told any number, and then they might just tell you, what's the percentage? What percentage of people are going to be, or, you know, what percentage of cars are going to be. So if I'm talking about percentages, if I'm talking about the whole scenario, how much of percentage is a whole scenario? It would be 100%. Is that true? So if you look in there, I'm just showing you. So if I did 100%, this shows me how many percentage is at each spot in the long term. So in this scenario, 33% ended up at the top spot and 66. Now, if you do 30 out of 90 times 100, you get 33%. Yeah? So I'm just showing you, you can, if they ask you a percentage steady state, you don't need to know any state. You can just chuck 100 in there and you'll get there. Okay, it says the initial state matrix SO and the transition matrix, then the steady state matrix is. So here, you can see I just put the transition in to a high power, times it by the state, and I got it. Now, because I want to prove that it is a steady state, I did it to 51 and made sure I got the same answer. So that one's pretty easy. Okay, there are 3 brands of chocolate that dominate the market, brand A, B and C. People change from one brand of chocolate to another, time from time. The transition is shown below, and it says initially there was 250 at A, 300 at A, 250 at B, 425 at C, and it says in the long term, so that's where you want to get the steady state. That's another way of asking. The number of people at each brand will be, so we are going to do that transition to a high power and times the state we came up with, and we'll get the steady state. So let's just, and we'll double check it to make sure that we've hit it at 50. Okay, actually didn't. Okay, so I got this to be, now we're going to round to people, so it's 43922. Now this one, it's a 0.5 there, and it's a 308.7. So I'm going to be careful here, because how many people in total have we got? We've got, what's that, 550, 975, yeah? So if I round this up to 439, maybe I need to make this one 227 and that one 308. Can you see that? Because if I don't, will I go over? If I rounded it to 228, wouldn't that put me over? Am I correct? Oh yeah, sorry. No, this one had to be 08 as well. Yeah, because it'll put it over. So this, only this would allow 975. So that was a case where you had to show it. Now I'll just double check I got the same answer if I did 51. And I did. Okay, so that was a case of where the rounding, what I'm talking about, we have to be really careful, and we have to make sure they add up. Okay, so with this one, it says when buying fruit in winter, people alternate between oranges and apples. So 75% of the people who buy apples will buy oranges next time. So we've got oranges and apples. We've got to set up our transition. And they said 75% who buy apples will buy oranges, so 0.75 from, oh, sorry, was that the wrong one? Yep. So, was it? Oh, no, apples to oranges, that's right, 0.75. And then, and 55% who buy oranges will buy apples the next time. So, this is 0.55. Now, how do I get those other two numbers? They've got to add up to 100. Good. So 0.25 and 0.45, because these have to add up to 1. Okay, so that's become my transition. And then it said, on the first day of winter, 85 apples. So, I don't know, if they're giving you state 1, you could say day 1, whatever, 85. Oh, actually, I have to make sure this matches. Like, this has to be O and A as well. And it said 85 apples and 120 oranges. And it says in the long term, all right, so long term is the same as steady state. So we're going to do the transition to a high power times the state we've got. Now, with this would be an answer where it just says in the long term how many are sold each day. So you really technically don't have to prove it. So you just get your answer and make your statement. But as I said, you're not going to get marked wrong if you're proving your steady state. That's okay. So sometimes I feel maybe it's better to have a bit to be safe in case you've read the question wrong or you're unsure whether they're really asking. So 120 over 85. So I end up with, now I can't go over 205, can I? So I've got to be careful. So 118 and 87. Does that give a total? So this was a total of 205. Is that a total of 205? Yeah, good. So therefore, remember, we've got to answer the question. In the long term, we'll have 118 oranges and 87 apples sold each day.